Okay, we have a lot to do, so let's not waste any time. We'll first create a new function to clean up our core structure. Now, despite this seeming somewhat hard, due to some decisions we've made consciously beforehand, it won't really be a problem at all. Let's start by defining our procedure. Let's call it delete frames and shells related to core. Yes, it's a long name, but we'll only call it once, and it's better to be explicit about its purpose. If we were to call it several times, we might have wanted to make it a bit shorter. Our procedure will receive the core center in x and y coordinates, the core lengths in x and y, and the total height of the building. We'll start by defining the usual tolerance of around 1 centimeter. Then, we'll select objects in a bounding box around the core. We'll do this by using the center coordinates and the x and y lengths. Notably, we'll keep our bounding box just short of the building top. This is because we don't want to erase the top floor slabs and expose our core openings to the outside. Now, this is actually also selected core objects which we don't want to delete. So, to deselect them, we can simply deselect all objects of the group by using the selection objects group function and giving it the core group name. Then, we'll set the deselect flag to true so that all objects of the core group are removed from the current selection. Right, all we need to do now is call our delete selected objects helper function and give it the value of 5 for item type so that it will delete all area objects of the selection. Okay, now on to the frame elements. This will be pretty much the same as before. The only thing we'll change is that instead of stopping just before the top of the building, we'll instead go slightly above the top floor slab so that we get the top frame objects. Then, we'll simply change the object type to 2 from 5 so that we erase the frame objects and not the area objects. Notice how we started to use quite a lot of our helper functions. If we were to do this manually every time we wanted to erase objects from our model, you can imagine how much longer our code would be. Let's just clear the current selection as usual, and let's call our procedure from the main application function. We'll do something quite similar to what we'd previously done. We'll only call this procedure if we know that there are core cells. And we'll call it after we divide the floor slabs by cookie cut. Alright, let's test our code. Great! There are now no floor slabs intersecting our core as before. Notice that we were able to do this because the parts of the floor slabs that intersect the core were already divided by the cookie cut method previously, so it was quite simple to delete them from the model. Okay, let's finish up by changing up some things in our code. First, we'll add some section cuts specific to our core. We'll change our add section cuts function to have an optional flag called IncludeCore that is set to false by default. Inside our bottom and top section cut cycles, we'll include a check to see if we need to add core section cuts, and, if so, we'll add the section cut with exactly the same coordinates. We'll just make a couple of changes. First, we'll set the group of the section cut objects to core instead of all. And we'll change section cut type to design wall by giving it the value of 2 instead of 1. Finally, we'll change the result side of the section cut to bottom and top respectively. This needs to be done because design wall section cuts don't automatically assume the result side to be in the direction where the normal vector of the defining quadrilateral points to. And let's do this for the top section cuts as well. Going back to our main function, let's change this function call depending on whether we have core cells or not by providing it with a true value if we have core cells. If we don't have core cells, we don't need to do anything since we already set the flag to false by default. Alright, we're just finishing up. Now we'll just create a new function to export the core section cut results. This will be pretty much the same as the other functions that export results, so we'll just speed this up so that we don't rethread past ground unnecessarily. And we'll call the core section cuts result function in the general results export function. Okay, let's create a new model. Run an analysis on it and export the results. And we're done. As you can see, we now have the results for the core section cuts. This concludes the SAP 2000 VBA Quick Start course. We do hope you found it useful. There is quite a lot more to explore in both VBA as well as the SAP 2000 API, but we encourage you to explore these in your own time. You should now be able to access SAP 2000 and integrate it seamlessly with Microsoft Excel. You should also be at least somewhat familiar with VBA utilization and some general good software development practices. While this was not a course on software development as a whole, we did explore quite a few concepts related to it that are used in professional software development. Thank you for choosing Structural Academy. If you're interested in learning more about SAP 2000, ETABS, or other structural modeling or CAD programs, please feel free to have a look at some of our other courses or technical articles that we've prepared just for you. If you'd like to contact us or subscribe to our newsletter to keep up to date with new courses and offers, you can do so in our website in the Contact Us section. Structural Academy, for engineers, by engineers.